Hey everyone, Simba Khadder here, and you are listening to the MLOps Weekly podcast. Today I'm speaking with Paul, who's a senior ML and MLOps engineer at Metaphysic, a leading Gen AI platform. He's one of our core engineers and is taking a lot of our deep learning products into production. He has 7 years of experience where he's built Gen AI, computer vision, MLOps solutions at companies like Core AI, Everseen, and Continental. He's also the founder of Decoding ML, a channel for battle-tested content to learn how to design, code, and deploy production-grade machine learning. He is just a really big part of the MLOps community and just creates a ton of really awesome content. Someone you should definitely follow on LinkedIn. Let's jump in. Hey, Paul. Thanks for joining me today.
Hello, Simba. Excited to be here.
So let's dive right in. I'd love first to maybe for the audience who doesn't know who you are and doesn't follow your amazing LinkedIn content, would love to get an introduction on how you got into MLOps.
Well, it's actually not a straightforward question. So my first interaction with the technical world, let's say, it started with software engineering and Python. And initially, at least from my point of view and from the people I had around, there was no difference at all between machine learning research, machine learning engineering, and MLOps, and so on and so forth. And this was 6 years ago. So at the time, these terms weren't so well defined. Initially, basically, I took the first job that had AI and machine learning in the title because I was mostly at the junior level in the field and I just wanted to learn. Yeah. So basically, I did not know a lot what AI is about. So I just took it. And actually, I turned into a deep learning research position where we research autonomous driving algorithms, like 3D object detection using images, LiDAR sensor, and tracking and that kind of stuff. And it was mostly about reading papers and trying different algorithms and breaking metrics and that kind of stuff. And I realized, hey, this is not for me. I don't like it. I like to build stuff, but I also like AI a lot. So I just started digging more into the field until I saw, okay, there's actually a field where you don't need to just build algorithms. You just need to take them and build the ecosystem around it, which is actually what most of the people out there do. So I changed my position into more of an ML engineering, still in the computer vision space, where unfortunately it was about engineering, but not that much about MLOps. And now I realize that people didn't know actually what MLOps is. They just knew, hey, I want to use all kinds of cool tools like MLflow and Triton and that kind of stuff, but they weren't really focused on MLOps principles. And it was everything very vague. And ultimately, I moved to the next company, which was very ML focused, and they actually wanted to sell this MLOps vibe. And I had the chance to learn a lot about this field because they wanted to create a wrapper over well-known MLOps tools so we can easily interact with the whole ecosystem. So we had an experiment tracker, a model registry, a data versioning system, and monitoring, and all of this. And that was the aha moment where I really understood what everything is about. So I would say that the journey was long, about 4 years long, until I really cracked what this is about.
One thing that you've done which is unique is that you have been both a software engineer and a researcher prior to becoming an ML engineer. In my experience, people tend to come from one side or the other. Maybe data scientists turn to MLE, or you sometimes get software engineers turn to MLE. But you're rare in that you've kind of jumped on both sides and then ended up in the middle. What skills, maybe first with software engineering and then from ML researching, but what skills do you think really mapped well, and what skills did not? Like what parts of being a software engineer are completely different from being an ML engineer, and what things are really valuable?
So basically the question is software engineer versus ML engineer, right?
Yeah, let's start there, and then I'm going to ask you the same question of research.
Okay, awesome. So from what I've seen in ML engineering, they still lack a lot of software engineering good principles, like object-oriented principles, good design architecture, and basically writing good and clean code. Because usually ML engineers, from what I've seen, they know just Python, and they follow this very pedantic way, not really Pythonic way, where you don't care about this stuff. You just put function in function in function, and you hope that everything works fine. And usually it gets a big mess. So I've seen many code bases that are just spaghetti code, and I don't like that. I'm usually very lean towards clean code. And I don't want to generalize here. I just seen this pattern many times. There are also other use cases where this is not true. And on the other side of the spectrum, I guess what is good about ML engineering and in the software world not, is that it completely shifts your mind towards like a data-centric point of view. So you don't care that much about APIs, data layers, not the database layer, the classic database layer, application layer, UI layer. Your main citizen is usually the data and the model, and you need to basically to completely shift how you think the whole application. And I saw that for many software engineers is hard to grasp for some reason, but I think it makes more sense because even in normal software engineering applications, in the end, it's all about data. Even if you don't have AI, you still have to manage a lot of data and to track it in some way.
Yeah, it's the key difference is you're working with things that are not deterministic. That's always like an issue I feel like people run into, at least coming from software engineering. Unless you've worked in distributed systems have similar, I feel like, aspects, which is why for me, I really love that switch. But if you're used to you just follow the code and see what happens, it doesn't really work when you're dealing with a model. You kind of have to observe its behavior, observe the data, and then try to kind of deduce what's happening. And that, I guess, goes into what you're saying, like the data, thinking from a data in, data out perspective, and less of like a programmatic like API call in, API call out. Is that fair?
Exactly. And that's why I think in the ML or AI world, experimentation and being able to experiment a lot and see how it behaves, it's a lot powerful than just going through the code, because as you said, going through the code leaves too many variables unanswered. And but based on this, one thing that I saw it has still a huge gap. It's writing tests, writing tests for machine learning applications, at least from what I've experienced, is a real pain. And I not mean like writing simple unit tests for like minimal parts of your code, which are deterministic. That's like software engineering applied to this, but writing like integration tests or tests that really see how the system behaves, it's really, really hard.
How have you seen it done well before?
I've seen it once, and like in a more simpler way, let's say. Basically, it just checked that the system works, right? So you start like the feature processing, the feature pipeline, you start the training, the inference, and you just check that everything works, the shapes are okay, that the interaction with the system works, but you never check that the result itself, it is what it should be. And it's hard. Just imagine how you can test that a training works without having an integration test that runs for a few hours. It's hard, especially with deep learning models. Like you can do some simple tests that check for a simple batch that the learning curve goes towards 0 or something like that. But still, it introduces issues like where you store the data for continuous integration pipelines, where you store the model, where you train it. Because with out-of-the-box solutions like GitHub Actions or GitLab Actions or these, they don't really integrate that well with the GPU world. You can do that, but it's not. You have to spend some time into building that infrastructure.
Yeah, that makes sense. I wonder if you were starting from scratch, like you had some researchers who'd like kind of found their way of getting models into production, and now it's not a clean slate because there's already models, but you're kind of the first MLOps person. You have to build that MLOps platform. What would you do? How would you go about it? How would you break it down? What would you do first?
Yeah, that's a really interesting question. So I think that the first thing I would try to understand is the system itself, because like to really understand what's going on. And let's assume, based on what I've seen so far, that most research-based deployment system have a big monolithic system where the features are and the training are computed in the same place. Usually you don't save any state. In some cases you have a model registry. So basically everything is completely coupled together. And this is not really scalable because, for example, if the features are directly fed into the model, you don't know, you can't track what is going on. Basically, you don't know that model was trained on what features. You can't reuse those features. And on the other side, if you have a real-time system, if a user makes a request and you don't keep a state, usually you have to transfer the whole state into that model to compute the features and so on and so forth. So what I would try to do usually is to apply this feature training inference pipeline methodology, which is a mind map that I really love. I think it was introduced by Jim Dowling from HopsWorks. And basically it splits your whole system into three abstract components. Let's say the feature pipeline, the training pipeline, and the inference pipeline. And it's not necessarily three pipelines, but it defines clear scopes and clear interfaces between these three. So just to go very fast forward, you have a feature pipeline that gets raw data as input and spits out features. Usually you store these features right into a feature store. And then you take these features from the feature store, you train the model, you put the model into a model registry, and on the inference side, you take the features from the feature store, the model from the model registry, and you make predictions. And this is not hard to implement if you have the right tooling. And it then allows you to scale really well and basically start to dig into the other issues. So I think I would try to apply one way or another this principle, basically to decouple these three components and create a clear differentiation between these three steps, and I guess find some tooling, some most essential tooling, which is a feature store or a logical feature store, and some other registry and some experiment trackers that they can basically track what they're going on and to make the system reproducible and scalable and modular.
Yeah, I like that breakdown. I wrote a similar one. I added the fourth component, which is just a monitoring evaluation. So then it would go like data, experiment tracking, and model store, deployment, which is really just the model deployment. And that's where you would handle A/B testing. You would handle, upgrading, downgrading.
And that would be like the fourth component where you...
No, that would be the third one, the same one you mentioned, the inference one. And then the fourth one would be monitoring and evaluation, which would just be the stack that actually, kind of samples or takes the predictions and the features and provides some sort of UI for you to monitor. So like companies like Arise or Aporia or those types of
that makes sense.
So then I would have those four. And then I always feel like a lot of what MLOps engineers do at companies is like, okay, like there's feature stores, there's, experiment trackers like just weights and biases, there's MLflow, there's Selden, there's Bento for serving, there's Arise, Aporia, evidently for monitoring. These tools are great. You don't really need to build your own anymore. You shouldn't. I mean, it's probably not a good use of time anymore. But what you need to do is more like, what's the abstraction above it? And I think that's something that is going to be super unique per company. Like, how do you do things? Like, we have companies and customers for us that work in notebooks. We have other customers who do everything via CI/CD and like pretty much use Python scripts. And just everyone's so different that you can't really like one size fits all MLOps platform. But anyway, yeah, it's just something that we the way we think about it's very similar. I feel like a lot of people have kind of come to the same abstraction, same realization. It's just slightly different tweaks of the same thing.
Yeah. Well, it's very intuitive in the end, and I love these four components. And it makes a lot of sense not to put it like in the inference pipeline, to put it like the meta layer that observes the whole thing. Yeah.
Yeah,
it made a click.
Yeah, I think it's like people forget about that piece, It's like, okay, I'm deployed, I'm done. And it's like, no, that's like just the beginning. Yeah. Like, good job. Like you made it to the starting line, like you're off to the races, but there's so much more to do. And I think,
Yeah, plus that, it makes a lot of sense like to add an out-of-the-box tool for monitoring ML models, because it's hard to do this yourself. To be honest, I tried once and it's a waste of time. It's really painful. A waste of time.
Yeah, painful to do a lot of this stuff from scratch. It just doesn't. The ROI has kind of gone down. In the early days, the tools were so new, and maybe there was an argument of like we could do something unique to us. But nowadays, all the tools are years old and used by big companies. Like it doesn't really make sense to start from scratch. But yeah, I agree. One thing that I've found interesting though is I've actually reapplied the same breakdown to LLMs and RAG specifically, and it kind of ends up looking the same. So what it looks like there, to me at least, is the data piece is pretty much the same. The big difference is, you're chunking, vector DBs, like slightly different types of feature engineering. But embeddings aren't new. Like we've been using them for recommendation systems and NLP use cases forever. And then training becomes kind of like an optional fine-tuning step. Serving is still the same problem. Like it's you have this big model. The only difference is nowadays there's like APIs you can use, like hosted models. And then monitoring is also like evaluation. I mean, the hardest problems in LLMs are ironically, in my opinion, the hardest problems in MLOps, which is data and evaluation.
Yeah, I totally agree. I very personally believe that evaluation is completely an unsolved problem in this field. Like you have solutions, but all of them are incomplete. And in my opinion, an incomplete evaluation solution will always leave you with a feeling of not trusting what it tells you. So you cannot trust, and if you cannot trust the system that has to make you trust the rest of the system, you always end up like feeling you don't really know what's going on inside there.
Yeah, it's funny because you see a lot of these like random tricks that people do, and some of them work or seem to work. At least there are papers written about them, but they just feel very wrong intuitively. For example, like a lot of people use the same LLM to evaluate itself and its own responses. And obviously that can work because, like, you know, if you talk to an LLM and it does something wrong, you're like, it was wrong, and then it will try something new. But so it's not completely like it can work. It just feels like, okay, like you've added a black box to your black box to make you feel better about your new black box. You know, it's almost like you're just adding. You're almost like, if I add enough layers of abstraction, it becomes so confusing that I'll just have to be forced to trust it because there's no way to like figure out what's happening.
Yeah, exactly. Yeah, you're completely right. But what's more even confusing is that sometimes it works and sometimes it doesn't using the same LLM. But what I've seen usually in the industry, that you can use like a smaller model for your open source use cases and all of that, and you usually use a very powerful model for evaluation, even if it's more costly and so on and so forth, because you don't want to evaluate everything. You probably just sample and evaluate that. And yeah, from what I've seen, that's like a reasonable solution so far.
Yeah. I agree. I think that one's more obvious and that one's clear. It's like I'm using a better model to check my weaker model. It makes sense. I think what's funny is when people use GPT-4 to check GPT-4, it's kind of like feels a little bit like it might work, but it just feels like, you know, surely in 3 years we'll look back at that and be like, yeah, that was a funny little idea we had.
Okay, so that's why the application failed. Okay.
Yeah, it's like, yeah, I mean, it's almost like looking at ML before MLOps, like the stuff we would do, just like the hacks, and any trick would work. And, you know, it's almost like we were so worried about the cool demos, especially with computer vision and things like that. We were so worried about the cool demo, but we almost didn't care about how often it didn't work. And I feel like LLMs are kind of in that same boat right now, where it's really easy to build an awesome demo. And I think even unlike computer vision, these demos tend to work way better in production just by default, but they're definitely not like production grade systems depending on what you're trying to do. Like most of them still have pretty high failure rates. But we're just like, oh, but look, you know, here's a few examples of it working. It's so awesome. Yeah. I get that. And I think that's going to start to go away as people get used to the kind of how good GPT is. Like I'm already finding for myself personally, when I use GPT-4, I used to like just be amazed every time. And now I'm like so used to it that I use it every day that like by default, it's like, this is great. It's solved some problem for me. And then when it misbehaves, I get more annoyed. I'm like, oh, I can't get it to like do what I want, or I can't figure this thing out. Or like you give it sometimes like an error message and it just doesn't know, and it just guesses and it's completely wrong, and you know it's wrong, and you're just like, oh, like. So I think that the hype is going to start to fade, and then almost like the bar is going to go up and people are going to want it to work every time, or almost every time.
Yeah, that makes sense. A lot of sense. Especially if you get annoyed that it will be just faster to Google it.
Yeah.
Sometimes. Yeah. To be honest, I still Google like error messages. I found that that's more robust, at least now, because usually it points to some Substack thread where people like try to debug it. But I think the only thing that I still Google is like error messages, because that's like usually a very standard string that is very easy to query and it still gets the job done. But yeah, I really try to force GPT many use cases that I found I need to automate. And I usually find I find myself very discouraged because it works, but it doesn't work good enough.
Yeah, it's almost like an augmentation tool to me. That's how I think of it. Like it makes me better, but I have to almost like supervise it. But I would be kind of freaked out to let it run and do its own thing, completely unsupervised, like completely automated. It's just, not only can it be wrong, it can get very convinced that it's wrong and then follow like a path that I'll give you a very specific example. I ran into this error, or one of my engineers did, one of my junior engineers, she was asking one of our senior engineers for help. And the error was something like proto needs to be initialized of a dictionary. And she Googled it, wasn't really clear. Then she asked GPT, and GPT was convinced that the issue was how she was initializing it. It kept spitting out code for her, and that code would continue not to work. And it would like continue to try different renditions of the same code. And then it turned out that the issue was actually that one of her fields was misspelled, and the error message was just awful. But the error message was really awful, and it confused GPT, and it almost wasted more of her time because she was just convinced, because GPT was so sure of itself, and she's not more junior engineer. She was just like, I just must be doing this wrong. But anyway, it's like lots of examples I found of it not only being wrong, but being convinced and being very like persuasive and that like, oh, it's probably just me. I'll just copy and paste this code or see what happens.
Yeah. Well, that's a very big issue. Like a stupid person that doesn't understand that it's stupid.
Yeah. Where do you think that like LLMs and MLOps, like LLMOps, let's call it, and MLOps, what happens? Like, do you think they're going to merge? Are they going to be separate things? Does one eat the other? Like, is MLOps over? Should we all change our job titles?
Well, personally, but this is just my personal opinion, to be honest, I cannot back it up by any official stuff, is that MLOps is just a subfield of MLOps. Because if you look, usually a lot of MLOps tools are very used for like tabular data, structured data. Almost all their demos until the LLM world appear were for tabular data, to be honest. So they did not took a lot in mind this deep learning world with this, where you need a ton of GPU power. You have big data, which is usually text or images, videos, and this kind of stuff. And as I've worked with deep learning before this LLM hype, and then break into MLOps, to be honest, I really saw a very big divergence between these two fields. I liked MLOps, but I couldn't see how to really apply it to the deep learning world. There were many lacking things behind. So to be honest, I see MLOps just MLOps for deep learning, because in the end, LLMs are just transformers used for text and images. It is just a fancy word for big models that take as input images and text.
Yeah, I think so too. I think I've seen two different schools of thoughts on this. One is the extension mindset of like, I'll take my MLOps platform and extend it to do LLMs. The only hugely unique thing about LLMs is prompts. Like prompts have never existed before.
Yeah.
The concept of a prompt is completely
Yeah, that's a good point.
But embeddings aren't new. Vector databases aren't new. Sure, they're way more popular than they were 5 years ago, but they're not new concepts. Transformers obviously aren't new. I remember when Elmo came out, that was like my first introduction to like using transformers in production. And then BERT came out, and I was super excited. And then people thought it was a little bit crazy because it's very niche at the time. Nowadays, obviously, it's clear that was the future, at least the next step. But yeah, I think there's an extension mindset. I think some companies I'm finding, the really big companies, that huge enterprises, are treating them different. But I think it's because more due to bureaucracy than due to anything else. Because to get their MLOps platform to move as fast as they want to move is like actually harder than just starting from scratch. But yeah, I think the best practice in the end, like you said, it's all data centric. It all starts with the data. So an LLM is almost just like another extension of your data. It's another tool that you never like plug into your data that's really powerful and you can use it in a ton of places. But in the end, it's just like, cool, here's a new screw thing I can put into my data. So I think a lot of the same. Yeah.
And the biggest difference is that the data is a lot different than what it was previously, and how you model the data. As you said, the prompts, basically that's how you model your data, which is a lot different. And to be honest, I see prompts at this moment, maybe it's a stretch, but I see them as part of the feature engineering step, because in the end, your prompt, you don't focus so much on how to clean automatically and that kind of stuff. You just, if you have better prompts, you end up with better embeddings that basically create your auto-regressive process better, which in the end are features, more or less.
Yeah, and I mean, to maybe even give you a bit more credit than I think you're giving yourself, I completely agree. And not only do I agree, I've seen it. Like, we have customers doing this, and how they would think about it. There's a prompt, which is a string, it's a template. And all of the inputs to the prompt are features. And they're exactly the same features that you would have done otherwise, right? Like a nearest neighbor lookup is not something that's new. We would do that for recommender systems all the time. And then, for example, if I'm asking a bank chatbot, how should I invest my money? It probably wants to know how old I am, my credit score, am I married, do I have kids, what's my risk profile, all that stuff, right? But all that stuff is in a feature store somewhere. And so how do you pull that stuff and also pull the nearest neighbor stuff and the dealing with the chunking, which is just it's not a new idea, but it's like that pipeline has become way more important than it used to be. Pull all that stuff together. And the only thing that's new is I have these templates. So rather than like old models where it's just like you just plug them directly into the model, now there's like this abstraction in between where you just fit it into a prompt. And I think in the future, that's what,
So basically it's just an abstraction layer between your vector that you feed into the model and your, basically what you said, how you take the data and plug it into some processes that transform your data into this vector. So you just don't care about transforming into vectors anymore. You just put in a prompt and my job is done.
Yeah, it's like an adapter. And I think unlike, it's not just like a dumb adapter. It's like you can add get a lot of value out of just the adapter itself. But yeah, I view it as just an adapter to the model. And in a way, it actually is more natural than, even if we move away from text and let's say we move to like JSON somehow in the future and we move to that sort of stuff, like it's still a nicer, it's almost like an unstructured input as opposed to deep learning models or traditional ML models. Input's very structured. Like this is what goes into every single input node, where here it's like, just give me information and I'll work with it. So I think it's like a natural progression, but I really do view that a lot of the issues are the same. They just look slightly different. It's more of an extension of what's there as opposed to like starting from scratch. I mean, we'll see. I mean, if some of the really crazy stuff works, like models, evaluating other models and models, the agentic stuff and all that really becomes what everyone does, and all the RAG stuff is almost like second to it. But I think it's not as obvious because agentic flows are just different enough where you just kind of want to do something new. But
it will be really interesting to have a model that tries to improve the prompt that it's an input to another model and just make them bounce together and have the perfect prompt in the end.
They actually do that. That's a thing. In fact, what some people will do is they'll definitely, I've seen that before, but it's like a thing where a user asks a query and then you'll have a LLM actually rewrite the prompt to achieve better performance. And then the other one I've seen, which is interesting, is for naive RAG, where people just do a nearest neighbor lookup, they'll take the prompt and then pretty much generate a summary or even like a mock response, and then use the response to do the embedding and then do the nearest neighbor lookup for RAG. So we're already seeing actually a lot of that stuff, and it seems to work well. But we'll see how much of that becomes the main feature engineering, or hyperparameters, or if it becomes data. And I think that's
on the reg side, what I've seen lately, and I know personally I like it very much, is this self-query step where which it works for well-defined applications, which most of them are.
Yeah.
Especially like in the more business world, where you kind of know what a user should input and what you should look for. And you do this self-query process where you put the LLM to find some keywords into the user question, like, I don't know, user age, location, or whatever makes sense for your business use case, and then map it to a hybrid search or filter vector search of some sort. And you can very nicely combine these two, the more deterministic world, and with this, this new LLM based and vector search based search that helps you find more nuances in your search.
It's funny whenever I end up talking about like LLMs in the podcast, because I know that this will go out in a few weeks, and who knows? And, it's just like GPT-5 gets released and, it actually kills RAG. I don't think it will, but just like, things are so explosive in that space. It's cooled down a bit, but it's still like hard. Everyone's kind of keeping their finger on the pulse because it feels like it changes every couple months. It used to be every week. Now it's every couple months.
Yeah.
But still, it's really dynamic.
Yeah. So, in the beginning, to be honest, I was reading like weekly about this, but at some point I realized that if you don't apply that stuff, like at the moment, it's pointless. Like, and I just try to focus on the fundamentals, like to keep understanding what's going on, but like going into all the details that I did not need at the moment was just a waste of time because of this. Like, you just don't use it in a few weeks.
Yeah, exactly. Yeah, I think as ML engineers, we have an unfair advantage because we know how to deal with like black box models. Like, it's not our first rodeo. It's different, but it's not like completely brand new versus people coming from more, I think, software engineering background. They treat it like an API, but they've never dealt with an undeterministic API before, where that's all we know. So I think there's an unfair advantage that ML engineers have in like figuring out what's going on.
Because they just apply it like a normal function.
Exactly.
They don't really understand what's going behind.
It's like Stripe. You just hit it and it just does the thing, and you just don't worry about it. But yeah, obviously not exactly how it works. Paul, I feel like we could go on for forever. I would love to continue chatting with you about this. We are getting to time. I want to be respectful of your time, and I really love that you were able to come on and we were able to have this great conversation.
Yeah, me too. It was really a great conversation. Personally, I also learned a lot from you, so I'm really excited to be here.
Yeah, me too. Thank you.
Thank you.